clip will guide students to self-practice the exercises themselves. The first, this video clips for the chapter session 2 is covering the optimal capital allocation using the maximum utility. But before jumping into the Excel exercises, first you must read these class notes and understand all these equations, the capital allocations. You must understand this, all the equations and the process and the procedures to complete this capital allocation, risky asset plus risk-free asset, and the rationale and all the graphs first. You must understand. Also, I strongly recommend you to read the textbook, this investment textbook, so that you can get the insight and understanding of these exercises. Also, you can read this slide that I posted from the publishers, but I strongly recommend you read the textbook and these class notes with which we discussed during the class. Otherwise, it's useless to jump into to figure out how to finish these exercises. It's totally useless. So based on the assumption that you already read this textbook or the class notes so let's go these exercises. The goal of this exercise is to find the maximum level of utility curve, and we'll draw this utility curve that make this tangent of the capital asset allocation line. So the first exercise is now to find the weight. Again, always the portfolio management, at the end of the day, we want to find the optimal level of the weight of the risk-free asset, or between two risk assets, or the security allocations. So we have two portfolios. One is the risky portfolio, and the other one is the risk-free asset portfolio. But once we combine this risky asset and risk-free asset portfolio, then finally we have this complete portfolio, C, right? So here, risky portfolio only, we have the 7% of rate of return risk-free asset, and the expected the rate of return of risky portfolio, and the standard deviation of a risky portfolio. We have the information here. Now, again, the point is, how much percentage of the weight out of the total complete portfolio we allocate on the risky portfolio? We can use the data, you can use the server function to find the weight, or you can use these equations derived from the utility. So by calculating this weight of the risky the portfolio, then just 1 minus weight is the weight of the risk-free assets. And we can calculate expected the return of the complete portfolio based on its weight of these risky-free and risky assets. And then we can also get this standard deviation of complete portfolio. The slope is important. Again, this slope, if the capital asset allocation line, we want to find this tangent point. When the utility at the risk aversion level, if we assume that this risk aversion score is 4, then we apply it here so that we can get the maximum utility at the risk aversion level, and then we apply this, and then finally we calculate this expected rate of return of the complete portfolio, and that satisfies this maximum utility. So let's jump into the calculation. Here on the weight, again, let's just put 0 because we don't know yet, right? This is just the design process. 1 minus this weight of risk-free, and then is 1%. But once we found like 0.5, and then automatically change it, right? So initial point is just 0. So here on the table, we'll see on the weight 0, 1, the 10%, 20%, interval 10% up to 100%. What is the expected rate of return and the standard deviation of a complete portfolio is, right? And then we'll find the maximum level of the utility of the investors. Now, once we get this weight, then the expected return of a complete portfolio is just simply, yes, just this risk-free asset now times where is the risk-free asset weight, right? Plus expected return of risk-free times the weight of the portfolio. Risky portfolio 15% times the weight of risky portfolio. So now currently 7%. Why 7%? Which is same as risk-free asset expected rate of return? Because the weight of the risky portfolio is 0. And standard deviation, how to calculate the standard deviation is from this equation, right? I don't want to explain this derivation process, but once you see the class notes, you will understand. So the complete portfolio's standard deviation is equal to now what weight of the risky portfolio times standard deviation of portfolio is from this equation, right? Out of total, the portfolio. Now, what is the complete portfolio? So this is the weight. Now, let's calculate the complete portfolio standard deviation from this equation. So just 22% now times the weight. So at this stage, we have the 0% complete portfolio standard deviation, but we'll update this. Slope, which is capital allocation line of the slope. How do you calculate this? Yeah, excess return over the standard deviation of the risky portfolio, right? Anyway, the slope of the capital allocation line of the risky portfolio can be the same as the standard of the slope of the capital allocation line of the complete portfolio. So it doesn't matter because they share the same slope. So equal the expected rate of return of risky portfolio minus 7%, which is now this denominator is, this numerator is now excess return over the portfolio's, the risky portfolio's standard deviation. So we have this now the slope, which is this slope, right? The slope here. Now, at the average score index for utility at the utility point at the risk aversion, this risk aversion level, we use this equation, right? As we discussed during the class. So maximum utility, now how to calculate expected rate of return of this. Seven minus 1 divided by 2 times at the risk aversion level 4 times now the standard deviation of the complete portfolio to the power of 2. So now we have this 7, right? So let's just link all this the level of the weights of the risky portfolio, and we want to find the expected rate of return and the complete the portfolio's standard deviation combination of these two, right? And then also we want to get this under the max level. What combination will generate the maximum level of utility, where what percentage of the weight we allocate on the risky portfolio? That is the point, right? So once we got it, now let's drag this area. We use the data, go to the data table, and column, because this is column, right? Column, input cell, what do you want to change? Right, this weight. This weight we want to change, and okay. Then, okay, it is now. By the way, where went wrong? I think. Oh, by the way, we didn't link. Yes. Sorry, let's get started from this link. I forgot to link. So, expected return of complete portfolio. And here, the 0% complete portfolio and utility score. Okay, so and then let's go to the data table again, and then column input cell. What is column input cell? Right, this the weight of the risk portfolio. Why? So okay. Then now we generate this, right? So as you can see here, what is the maximum score of utility? Right, it's around 8.65, right? When the weight of the risky portfolio is 0.4, 40% we apply we invest to the risky portfolio, where this complete portfolio expected rate of return will be 10% with the 8.8% the standard deviation, right? So we also drew here, this is the capital allocation line. It's combination where this slope of a capital allocation line share the same, right? And then this starting point is now the 7% risk-free asset, and then we drew the capital allocation line. If the x-axis is the weight and y-axis is utility, now this is not the indifference curve. Just the graph with this x-axis with a weight and the y-axis utility. So we can find here around 40% of the weight of the risky asset portfolio is the maximum point of the utility, right? Utility. But we want to find the exact the weight of the risky portfolio weight, right? Here. So how do we find? We can use this equation. Directly. We can calculate expected rate of return of the risky portfolio. For example, let me just calculate. Open the parentheses. 15% minus 7% divided by risk aversion 4 times, let me just make one more parenthesis, and the standard deviation to the power of 2, which is variance, right, to the power of 2. And we can find this exact point, right, the exact weight, 41%. Or you can use the server if you want to find this set objectives maximum. We want to make this maximum. Okay, let me close. Then let's calculate one more time using your server. This set objective, this utility at the risk aversion level of 4 maximum by changing the cell of this weight, so we can get also the same result. And okay, anyway, we can get the same result. So we find here 41% of weight of risky portfolio when we invest. Then the investors, your clients, will satisfy with the maximum utility, right? Maximum utility. So in this case, now we want to find this, right? The indifference curve. That means here the optimal portfolio, a complete optimal portfolio where this they satisfy with this the standard deviation. So how do we create it? So here I want you to copy of this utility at the risk aversion level and paste. But when you paste, don't link these two. Don't link these two. Never. Because when you create this, the expected rate of return of the complete portfolio on the each weight of risky portfolio level, and will draw this indifference curve. So don't the link copy and paste. Instead, we paste with only paste values, so that okay, you put these hard numbers there, right? Okay, then let's make this. Let's return this 0. So let's calculate the expected rate of return from this equation. Let's leave this expected rate of return of the complete portfolio alone, and then take this 1/2 a risk aversion score 4 times the variance of this complete portfolio, the other side. So we have this equation, right? So how do we get it? Now we want to fix F4 now plus or minus plus 1 divided by 2 times 4 times this variance to the power of 2. Enter. And let's drag it down. So we drew this indifference curve of the investors when they satisfy with the maximum level, which is this point, and we find, what is the point again? What is point? Let me just, this point. We found 0.4132%. Let's calculate one more time. Data, server, yeah, 0.4132, right? That is this point, Oh, this graph is broken because again, we want to see what is the optimal, what is the weight of risky portfolio level that satisfy the maximum level of utility. So let's come back here. Okay, so we drew this indifference curve that makes the tangent with the capital allocation line. Now once we find this, the weight of the risky-free and risky portfolio asset, what was the the 0.41 and 0.59. Now let's find the weight of the risky portfolio, weight of risky assets on the risky portfolio, which is the asset allocations, right? In this asset allocation, with the minimum variance portfolio, with the 2 risky asset portfolio, we'll cover on the next video clips. You guys, bye-bye.